Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thanks a lot, Anna, for the nice introduction. A very good day to everyone who is joining our session. And welcome to the AI for Good Machine and 5G Challenge webinar session. My name is Thomas Baskol from the International Telecommunications Union, ITU. The Machine and 5G Challenge aims to create a community to solve network-related problems using AI and machine learning. And today I'm very excited to host this webinar, which is a challenge finale for the fourth impact analysis for 5G using AI and machine learning. And this webinar will cover presentation from the top 5 teams of the competition that we hosted in coordination with Zindi. This is our platform partner that graciously helped us to host this competition. And I'm happy we had good participation for this competition. And by attending this challenge finale, you will gain insights into the latest advancement of AI and machine learning as applied to 5G networks, but also you will see cutting-edge solutions for AI and machine learning for this problem. So I would like, without further ado, invite our first speaker, Antonio, to give some opening remarks. He's also the host of this problem statement. So Antonio, good afternoon.
Good afternoon, everyone. Good afternoon, everyone. Thank you, Thomas, for giving me the floor, leaving the floor, and I hope also that you have enjoyed. Everyone has enjoyed the challenge. So I will go through some slides I prepare to discuss together the challenge, introducing again before to leave the floor to the participant. So the name of the challenge is Fault Impact Analysis for 5G using AI ML toward service-oriented network operation and maintenance. So a quick recap. Network operation and maintenance in the 5G area had become more complex than ever. This is due to the higher complexity of 5G network with respect to the previous generation of communication network. In fact, in 5G, we have a larger number of frequency band, multiple deployment scenario. Operators are investing much more money to deploy and operate the network. As power consumption increase, there is a more complex network, means more parameter, but also to configure, but also more alarm to manage. And also 5G has enabled a large and heterogeneous number of businesses with new use case and services. So one of the most significant activity in RAN operation and maintenance is network fault management. So what is the challenge in fault management is due to the, first of all, uncertainty and non-stationarity of fault impact. This is due to the intrinsic characteristic of the mobile network, radio propagation, user mobility, traffic demand vary in time and space. As I said before, radio access network is become much more complex. No, we have a very large number of and different type of site, very high number of bandwidth, with operating a different type of frequency, more than 100 terminals, and more than 4,000 parameters to configure or optimize. In addition, customer segmentation has also increased due to the number of use cases. We have also different requirements and different applications operating to the network. Okay. Besides that, we have also other number of sources and of fault external to the RAN that may appear. Okay. So in this context, traditional network fault management has to evolve. Firstly, because today this fault management relies massively on manpower. There are front office people monitoring KPIs and alarm, back office staff that does the root cause analysis, and field engineer that operate on the fields and do the actual repair in the network. So this massive data increases with has increased the root case analysis complexity. In China, we can see that there is more than 1 million of alarm which are raised every month for an operator with managing the 8,000 RAN site. So in addition, there is a complex network relationship between the root cause and the type of alarm that are raised. All this heterogeneity, all this complexity lead to redundant work order and large mean time to repair, which we want to reduce, we want to optimize. So one way to do this, obviously, is using AI, and that's why we are here today. So in particular, in this challenge, what we wanted to do is to predict the impact of faults on radio access data rate. The data rate is one of the most important key performance indicator in the RAN. And allowing to the operator to do this, to solve this problem, will enable to better use the limited resources for the operation and maintenance, and to drive the network operation maintenance transformation from equipment-centric to service-centric. So what we want to do is to go from a manually to an automatically operation and maintenance, and from an expert-driven to AI-driven system. And this concludes my my introduction to the challenge.
Thank you so much, Antonio, for introducing the challenge. And also, I would like to just give a few statistics on about the competition that we had this year. So I'll just go through a few slides for everyone to understand how we have run this competition this year. Okay, just a moment. Okay, thank you so much. So in 2023, the ITU AI ML Challenge has been hosting several problem statements. We have run about, I would say, 11 problem statements that are related to ML and 5G. You can see on our challenge portal. And fault impact analysis is one of the problem statements that was hosted, graciously hosted by Huawei, and we are very thankful to colleagues from Huawei. So this is a quick background on what I'm going to cover. I'll quickly pass through these slides so that we don't waste much time. And as you can see, this fault impact analysis, we started the discussion curation phase with our colleagues at Huawei around February up to April is when we had the data set. And from May, we opened the competition. Everyone is happy, have the competition, you have the data, you start working on machine learning solution. By September, everyone is done with the competition. This is submission. And in September, we have been evaluating the solutions. And now we are here today, 5 October, to award the winners. And thank you everyone for participating to this competition. We enjoyed the journey. I hope you have learned a lot. And I hope you can use what you have learned in this competition for your, I can say, your university or academic research or in your future career prospects. Now, I would also like to mention that for this year, we have several hosts of problem statements. So we have Arizona State University, Barcelona Neural Network, Huawei, NIST, Fraunhofer, ULAC, ZTE, UPF, KDDI, Rising Japan, and of course, AI for Good has been hosting several problem statements for this year. So we are thankful to all the hosts. And of course, at this point, I'd like to mention Huawei, who have graciously hosted this particular problem statement. In terms of statistics, we had 232 people who enrolled to participate in this competition, and out of these 232 teams or people, 94 submitted a solution, and they have made a total of 4,175 submissions. So we had quite a number of submissions for this competition, and 47 countries around the world. This is the distribution you can see down here. And of course, we had 22 participants from African countries. And of course, in terms of gender distribution, we are still lacking in the whole STEM field. We need to do more to encourage female participation. This is not something that is standalone, but we need to make sure as a community, we should encourage, of course, our ladies, colleagues to participate in these kind of competitions or in these kind of projects. And in terms of the prizes, very interesting prizes. We have cash prizes. For the first winner, they receive 4,000 Swiss francs. The second one, 2,000. The third one, 1,000. But also we have a winner certificate from ITU that will be sent to these participants or to these winners. So the total cash prize is 8,000 Swiss francs. At the same time, we also have, we also have cash prizes for the 4th and 5th place. This is 500 Swiss francs. And we have internship position for the winners. Now, there's a star here because for Huawei Paris to give out internship, they give out to student participants. So amongst these winners, those who are student participants, they would qualify for the internship, but of course, it will be at the discretion of Huawei Paris to decide which team or which person to give this internship to. But of course, the internship position is open and is there for the winner, one of the winners of this competition. Okay, I would also like to thank or to appreciate our partners, Huawei, ITU AI for Good, and of course, amazing people at Zindi. Thank you so much for all the good work we have been doing to help us reach this far. And also, I'd like to mention that we have a new special issue, a journal special issue. Every year when we host the AI Machine 5G challenges, we have a special issue on solutions that have been submitted to our competitions. Now we are preparing the 4th edition of this special issue. We are opening the call for papers this month in October, and the deadline for submission is January 2024. And we are lucky to have Dr. Paul Harvey from University of Glasgow as the leading guest editor, who will be the overall editor-in-chief of this special issue. And don't worry, for authors, you don't need to pay to submit your solutions. What we require you is novated to have unique ideas, not just reports, but unique papers. And we encourage everyone who have submitted to our competition a solution to write these papers. They will be peer-reviewed by professors, by colleagues from academia. So this is an academic journal. Please make sure that you submit your solutions. And of course, you can join our Slack for other conversation. And yeah, thank you so much for participating. And now we are going into the presentation of the top solutions. So the format is we have 10 minutes for the presentation. So each one of these top solutions or top 5 participants will have 10 minutes to pitch their solution. And then we have 5 minutes for question and answer. Those of you who are on neural network, you can, on the video wall, you can type your question and we'll take them during the Q&A. So, and the sequence, we have first Julius, who is going to go first. This sequence is in random order. There's no other order that I could find. This is randomly selected. So Julius will go first, then Isak, Krishna, Adetomiwa, and then Caleb. So make sure that you're prepared and then we can start off. So Julius, are you ready for your presentation?
Yes, I'm ready. Hope you can hear me.
Okay, yes, we can hear you. So go ahead to start sharing the screen.
Thank you very much. confirm you can see my screen?
Yes, please go ahead.
All right, thank you. My name is Julius, and I'm a master's student here in Kenya at the KCA University. And I'm happy to be presenting for this problem statement, fault impact analysis. And I'm going straight to my work. So the agenda, I'm going to have an introduction. Then after the introduction, I'll have my solution, then results, discussion, and conclusion. Introduction. Telecom operation and management requires efficient fault management. So currently, the traditional way is to work with rule-based approaches for managing faults, where the alarms are handled by people. So the focus normally is on fault detection rather than analyzing these faults. It's actually also very manual. Depends with the expert assessment of the key performance indicators. It is also very difficult in resource allocation due to the correlation of the KPIs. So, and then there's also inaccuracies in how the fault is assessed. And this could lead to negative effects on customers, e.g. data rate reductions that may make the customer churn and move maybe to another competitor. So accurate fault impact assessment is very crucial for network reliability, and AI-based solutions for fault analysis can help alleviate the problem with the traditional approach by automating the process through AI, focusing on fault analysis, impacts of fault on networks, and in the process, transform fault management into a service-centric paradigm. Proposed solution. So for this competition, I had the option to treat the problem as a time series, but I decided to treat the problem differently. So my main concept was to use the previous hour's key performance indicators to predict the change in the data rate for the current hour. I used two tree models, that is the cut boost and the light GBM, which are very, which have shown good performance in competitions, especially on tabular data sets. Then the results were combined. So the advantage of this approach of taking only the previous hour key performance indicators is that there's no need to track lag features, which can be prone to data leakage if not carefully done, especially if somebody is lagging with looking ahead, looking into data that cannot be there in real time. Yeah, so there's also no tracking of moving averages and such kind of features. In the process, there is reduced complexity of the models. They become easier to understand, implement, and maintain. There's also faster training and also inference. So my solution, I believe, benefited very much from data cleaning. I realized that the data set from real world is normally dirty. That is usually the case. So I first started with data cleaning, where one thing that really boosted my performance, or the performance of the models, was that I realized that there were the data that was given was such that it gives non-fault data. Then after some hours, then we see fault occurring. In some cases, the fault would occur for quite some time. So I just considered the first instance, the first occurrence of fault in each row, and then I ignored the rest proceeding. I also excluded rows with zero data rate and zero fault duration. So they were not relevant for this because you are tracking the data rate change And if a certain row had the 0 data rate and the fault duration was also 0, then I would discard that. I also removed some rows with null values, which resulted from shifting the previous day. I also engineered 30 new features, hand-engineered features. So in the totally, I had that engineered plus the 7 KPIs, so amounting to that 7 features for my model. Yeah, so some of most notable features were time-related features, especially the hour. The hour really determined or impacted the model so much. Yeah, it was one of the most important feature in my models. I also got another feature, duration before fault. I wanted to track how many hours had lasted before the fault occurred. I also did some KPI combinations, such as ratios, which highlighted disparities as well as harmonies of the key performance indicators. And also I discretized the continuous features. These were the fault duration, so that they belong to certain categories. Yeah, and then I split my data into 80% for training and 20% for validation. So the catboot classifier and the light GBM classifier were used. I realized that data contained missing values, and no matter how much I tried to impute them or drop the rows or drop the columns, the performance of my model would be affected negatively. So in the end, I decided to just choose those models that can handle or can work with null values. So I chose CatBoost and Light GBM, which have that capability. I also predicted probabilities of class 1, that is a fault that would cause the data rate to change to the negative. I used probabilities for that. And then finally applying thresholding as a post-processing. So the results were assembled in a novel way. Yeah, so if for a certain hour, at least one of the two models predicted a 1, then I would argue there is need to worry about the fault, as it would cause data rate reduction. But if both models predicted a 0, then there was no need of alarm. Performance. So definitely we were tracking the F-score, but I decided also to have a peek how the precision and recall was for the two models. And I realized that recall was slightly always higher for the models than the precision. And the F-score for the cross-validation with an 80-20 split, I got the light GBM at around 0.706, while the CatBoost model gave 0.701. So the F1 score for the private leaderboard, when now validated using the data that was withheld, the models performed 0.722 versus 0.724. After assembling, the models got a 0.749 score. Yes, so future work. I believe in the future, there's something I didn't try, that is hyperparameter tuning, that is trying to optimize the model performance, maybe grid search and cross-validation. I also feel that I could have maybe hand-engineered more features, e.g. to explore additional relevant features to enhance the predictive capabilities. I also believe multimodal data fusion can help, combining run KPI data with other network-related data for holistic analysis, e.g. having the location of these stations. So maybe that could have boosted our scores a little bit. Transfer learning and generalization. So maybe we fine-tune the model on diverse data sets for robust performance, treating the problem as a time series. Maybe that could also maybe give better performance. And then, yeah, future work can also do some real-time and adaptive analysis trying to adapt the model for future.
Julius, just to let you know, you have 30 seconds left.
Yes, proactive real-time and adaptive analysis, just for model to check productivity in the photo management process. So that was basically it. Yes. Thank you very much.
Okay, thank you so much. So now we go into the Q&A. If we have questions, I would first maybe put it to Antonio and Vishnu to ask some questions, and then I can also check on neural network. If there's questions, we can take them. So over to you, Antonio and Vishnu.
Thank you, Julius, for the presentation. I want to say that I really like your report. And also the presentation, you clarify why you didn't focus much on time feature, time-related feature. I wanted to ask you, what did you find as between the complexity, different challenge? What do you find the most relevant, the most hard to tackle in this project?
In my report, I talk about how I could not reduce the log loss when I was training to check how the models will perform. I realized that the log loss for the training was quite low, meaning the model was very accurate on the training. But when it came to the 20% validation, I saw that the model really did not perform very well, because the log loss hovered around 0.6 versus around 0.2 for training. So I believe that these complexities were caused by the issues or the complexities that are mentioned in the problem statement. That there is the issue of stochasticity, issues with user mobility, and propagation of the radio waves and such. I believe there's that complexity that I could not be able to reduce the log.
Okay, thank you.
Yeah, thank you, Julius, for that nice presentation. Just a question on the resources that you used and the time that you took for training and testing. So, how much could you explain, like what was your experience in training and testing timings and the resources which you used, please?
Oh, thank you so much. That's a good question. Because I was using two models, I tried to track how the two models, the light GBM and also the cat boost, were performing in time, and I realized definitely light GBM is quite faster. So in about a minute, I could get my results. But for the cat boost, it took around 2-3 minutes between the models. I had a huge data set. Just to point out, I had around 400,000 rows to train. So that one maybe made the cat boost take more time, a little bit, but roughly 3 minutes both of them. I hope I answered your question, Vishnu.
Yes, thank you. Thank you very much.
If there is no other questions, then we can move on to the next presenter. So the next presentation is from Isak. Good afternoon, Isak.
Good afternoon.
Yes, so the floor is yours. You can start presentation.
Okay, thank you. Okay. Okay, thank you. My name is Isak Brown. I'm from Ethiopia, and I got third place in these competitions. Okay, I will present my proposed solution for fault impact analysis on RNA KPIs. So when we see introduction, the fault impact analysis with traditional methods has different challenges because of the stochastic nature of RNA KPIs, the complexity of RNA network, and the customer segmentation and the non-RNA fault makes too difficult to predict by traditional way. So the machine learning methods can help this problem. This may helping it to prioritize the fault and allocate the operation and the maintenance resource more effectively, and to improve the reliability and the resiliency of network and the service. Okay, when I go to my proposed solution, yeah, we have data collected data, so we just started from data cleaning up to testing of our model. So I will present each of these. When we see on my data cleaning step, a data set had 52 required non-fault data points. So we cannot use this for model, or I dropped this rows. And the sum also contain less than 0 relationship. So I replaced them with 0. And the sum also had more than 1 hour gap between fault and the non-fault data point. When we see the feature engineering technique, what I use in this project, I use mostly differencing and the ratio of KPI features. That means I take the difference of the change of in each hour, because the original data rate pointers cannot give enough information for the model. So I use the difference, that difference gives to model how much changed in each hour, and so the model can get important from this kind of feature. And another technique I was used is unbinarizing of this difference. So what that means, just if the difference is greater than 0, label as 1, and if less than 0, that will be 0. So this kind of engineering help to avoid outlier when we take the rolling mean of a difference. For example, we take this example. If we have two data points, that means this one is -3, 10. Then in last hour, this data point is reduced by 10. And then this second one is increased slightly from 1 to 3. So when we take the mean of two of these, the first one is will be mean 9, and the second one is 1. When we give this kind of mean for model just overfit on this kind of feature. When we analyzing this, the model can see the good information from this and avoid the other impact, the difference. And another one showing the KPI feature, that is also work like a differencing, just dividing the previous hour from current hour. Like this, we can get for each hour the ratio of each hour KPI change, KPI feature change. This also give an additional information for models when we have a high range of data. Some network data rate change in high range. For example, if we have some range, for example, this one is 2.3 up to 4.6. This is increased from 2.3, like almost double increase. This one is increased from 120 to 130. When we give the difference of this one has more difference. But when we compute the ratio, this one has high ratio, and this one is highly almost double increase in this hour. So the model can understand and give more weight of the range in KPI features. And I also used lag and rolling features. I take 24 lag features. That means last 24 hours value. And also I taken the rolling mean, max, and the mean. Also, I used binding numerical columns. That means fault durations bind into 10 categories. That means representing each category 6 minutes, and also relation column being 10 category that also represent 0.1 of the range. Another one is combining 2 or more columns. How this works? For example, we take this hour with binding of fault duration, and they can combine week of day with fault duration, bind of fault duration. This kind of feature engineering also help me give more importance for our model, my models. Also binarizing difference 1 and the difference 2, 3, then combining them. And this kind of feature also had high importance for the models. This kind of engineering, I was create more than 20 columns. Also, I use mean encoding methods. How I take a mean of how the KPI feature change in each hour, and combining this, how does this work? By grouping by network ID and the hour, then combine the mean, max, and mean. So this kind of feature engineering had high importance than others. Also, I use some targeting coding. I use like in hour and in day, I take the target mean. Also, I create a small function that can subtract, add, or multiply each column, and create some new columns. I use this kind of feature engineering. And I use the LGB feature importance to select feature to our models. Although this problem was binary, and also accuracy was F1 score. So data level class also slightly imbalanced. So I use stratified cross validation strategy. I split into 10 splits. So most of time neural network still cannot defeat the tree-based model in tabular data. So I use this tree-based model for this task. Okay,
You have 1 minute, so please fast forward. You have 1 minute.
Okay. Okay, model result is look like this. LGB had a high local score, but has low local private score in private leaderboard. My stack of these two models was 74.95. This most important feature was data rate, and the data rate mean by network identifier. Okay, In future, I plan to address this limitation by some limitation I had in future section and in future engineering because of time. I didn't use correct and the most effective feature selection method. I didn't use. So I try to use correct feature engineering technique and selection technique. I try to build the same model because in these data sets there is some kind of seasonality. So I try to build the same model. So this machine learning model has great result in fault impact analysis. So this machine learning method help to fix this problem. And thank you.
Thank you so much. So now we have 3 minutes for the Q&A. Antonio and Vishnu, over to you.
Thank you, Isak, for your presentation. I think here in Huawei, we have appreciated very much your in-depth data analysis. So that I think it was one of the key of your model. What I would like to understand is whether you have tested the results of your proposal with less feature, and how much the performance would have been decreased if instead of using 500 or 300 feature, you would have used 50 feature or 30.
Yeah, I created more than 30,000 features, and I think that kind of method, there was some limitations. I realized some my fault on that projects, and I didn't use a correct feature selection. Eligible feature importance method is not for this feature selection, and I think that was a problem.
Okay. Thank you.
Yeah, I don't have a question, but thank you, Isak. And the one observation I think related to your conclusion is that there are multi-collinear features, and I believe you have taken the approach of combining some of them. In your presentation, you did mention that some of them were combined into one column. Maybe that kind of studies is quite interesting, and thank you very much.
Okay, thank you.
Okay, so I don't see any other questions on the neural network. In this case, we are going to move to the next presenter. So the next on the line is Krishna. Good afternoon, Krishna.
Hi, everyone. Good morning, good afternoon, and good evening to everyone attending from different parts of the world. Thank you for coming up and attending the presentation. So I'll just give you a brief idea about who am I. So I'm Krishna Priya. I am a data scientist currently based out of India. It was exciting to participate in this particular challenge. I'll be moving straight towards the problem statement. So the two of the presenters before me have already covered most of the data and the analysis behind it. I'll just give you my view and my EDA on the particular data. So the data was, so this particular data was for a particular network element, any, and in total we had past history of each network station. And for each network station, once a fault is observed there, we had to predict whether the data rate would decrease or not. So that was the task given the data set. Now, for a particular network ID, we had a early timestamp, and for that early timestamp, we had 6 RAN KPIs, and then we had the data rate. Now, using the data rate column, we had to manipulate the data in such a way that we create the target variable, which is the binary feature, right? So, and the evaluation metric for this particular challenge was F1 score. So that is all about the data that we had. So from the historical data that we had, the training data that I made consisted of approximately 7,000 rows, and the testing data that I had was around 1,900 rows. Right. So now I'll walk you through the data set, and I did some EDA on the data set, and based on the EDA, I had some observations for the data. So I gave you a brief idea about the data in the earlier slide. Here you can look at a sample of the data. For example, this data is for one particular network ID. For one particular network ID, you can see that, you know, for at a 1 hour interval, you have these 6 different KPIs for a network station, and for the same timestamp and the network ID, you also have a data rate for that particular hour. Right now, for the same timestamp, we also had fault duration. Fault duration 0 means that we did not observe fault at that particular hour. Fault duration greater than 0 means that, you know, we observed fault at that particular hour. For example, from this particular snapshot of the data, we will have to predict that at timestamp 0 hour, once we observe the fault rate, whether our data rate dropped from the previous hour or not. In this particular case, yes, it dropped from the previous hour. Right? And this relation column is basically whether the fault was observed at this particular station, far away from or far away from this particular station. This particular diagram is just to give you an intuition of the domain. As we have spoken earlier, that the data rate of a particular network station at a particular time is affected by whether the fault was observed at that particular station and different KPI and KPIs. Right. The one of the initial observations from the data that I had was that out here you see that, you know, we have the data at each 1 hour interval, but not necessarily for all the network IDs we had the data for each 1 hour interval. There were few cases wherein we had to predict the data rate decrease at a fault at an hour where the fault was observed, and the previous row had data before 9 hours or before 10 hours also. So it was not a continuous time series, or I can tell you that it was not a perfectly sampled time series. Right. So this gave me an intuition that along with the past KPI values, how far in time was the last values was also an important factor. Should also be an important factor to modeling. Right. Now, there was one more observation from the data is that at the time of the fault, although in the training data we had all the KPI features, but in the testing data we did not have these KPI features. So if I would have used these features as part of the training process, the model would definitely fit properly on the training set, but it would overfit on the training set, and the testing results would not come fine. So that is why the first intuition was to delete these rows altogether from the training itself to avoid overfitting. If this would not have worked, I would have tried different ways of imputing this data in the test set. Now coming to the feature engineering, the very plain and simple feature engineering, I created lag values of lag values of the KPI features 1 to 3 lags. More than these lags, creating more lags were overfitting on the model. Second feature engineer was the one I talked earlier, the current samples timestamp, difference of the current samples timestamp to the last to the lagged values timestamp. Then I also created 3 different lag variables to give the model an intuition about that particular hour's KPI value, which is 24, 48, and 72. Right. And after that, I extracted time series based features, which is month, day, hour, because it could also be that for a particular network station, based on the location that the network station is located, the traffic varies between hours of the day and the day of the month, and that could also lead to a drop or increase in the data rate. So that is why these time series features were important in the model. And then the last feature was sign and cost transformation of the hour feature. Now what happens is, you'll see in the next slides that we have chosen a tree-based model. Now what happens is that these hour features range from, let's say, 1 to 24. Now, although it might seem that 1 and 24 are the farthest data points, but in reality, they are the closest data point. So you have to somehow transform the feature such that this particular domain knowledge gets incorporated into the model. And that is why when you sign and cost transform this a particular feature, what you get is the combination of those two data points. When you plot in a 2D graph, you will see that 1 and 24 will correspond to a single point. That brings a circularity in the cylindrical features. So that is why this transformation was done. Now this was the first set of features. The second set of features were to give an aggregate to give an aggregate statistical property for a particular network ID in the model. So the first set of aggregate features were for a particular network ID and an hour. I calculated the different central tendency values for the 6 RAN KPIs and the data rate. And along with this, third set of feature was for that particular network ID and the hour just before that, the same central tendency values were calculated for the RAN KPIs and the data rate. Now, to just give you an intuition why these features were created, because I just wanted the model to understand that for this particular hour and for this particular network ID, this was the distribution of the data rate in the past, and now the hour just before that for that particular network ID, what was the distribution? So that is the complexity that I wanted the model to understand. Now moving on to feature and model selection. Feature selection was very simple. Removed all the columns which had less than 1 unique values, basically no variance in the feature, and removed all the columns with more than 75% null values. Now for the model selection, as we know that we only had 7,000 trained data points, neural network was definitely out of scope here. Remaining choices was bagging and boosting model. Now since we had lag features in the model, the random forest in theory supports null values, but the sklearn API does not support implementation of handling null values. So I went ahead with the remaining models for the boosting models. Now the boosting models that fit all the criteria of smaller data set and the null values were these 4 boosting models: light GBM, cat boost, XGBoost, and hits gradient boosting. Now these boosting models could overfit on the smaller data set, but steps were taken to avoid that overfitting. Now, what were the steps taken to avoid the overfitting? First thing, we implemented a 10-fold stratified k-fold. Second, we implemented early stopping. Third, feature fraction. Now, all these things were implemented to stop the model from overfitting on the train set and not fitting properly, not applying well on the test set. We also introduced small L1 regularization term. And then the most important parameter to tune was scale pose weight. Now scale pose weight is nothing but a parameter in the tree models, which basically gives higher weightage to the minority class and in the objective function. So rather than manually thresholding and post-processing the output, you should be tuning this particular model, and the cost function of the model has to be tuned in such a way that imbalance is handled. Right?
1 minute to finish.
Yes. So, and the final evaluation, since the evaluation metric was F1 score, in some of the boosting models, F1 score as an evaluation metric was implemented beforehand, but for some of the models, for example, light GBM and XGBoost, F1 score is not available as a default metric. So this was custom coded and passed in as evaluation metric in the model, such that the modeling is also done on the metric on which, which is the competition's evaluation metric. So all these 4 models were made on different set of feature set which I described, and the final set of models were on all the 3 set of features. And what we see is the final model, or the 4th set of models, which had all the features, performed very well on the local and as well as the private. For the sake of the competition and to be safe, I took harmonic mean of all these 16 models, which came out to be a private leaderboard of 75% F1 score. But if you want to pick just one single model, I would highly suggest you to pick a single model, light GBM model out here, which has a better private score, 76%. Now, the final conclusion is that for productionizing, as we have seen that the final light GBM model, which had all the features, was performing much better than the ensemble. You should definitely choose it if you try to productionize the model. And if you ask me what could be upgraded in this particular competition, I would highly like to see that if we introduce latitude and longitude as features, this could give a better prediction for this particular problem statement. That is it from my side. Thank you. Any questions?
Thanks a lot. We go straight into Q&A. So Antonio and Vishnu, the floor is yours.
Hi, Krishna. Thank you for your participation, your presentation. I want to say that I think you really boosted all the participants with your model and raised the quality of the overall competition with your ideas. So my question is a bit out of what we discussed so far. I want to ask you whether the models that you propose would also work if instead of a classification problem like the one that we have here, I would ask you to estimate or predict rather estimate maybe the correct word, the data rate after default. Not whether the data rate, I think, decrease or not, but the actual value. And how this question, this target would have impacted your model design.
Right. So see, for example, currently on the problem statement, I try to predict the probability whether the data rate would increase or not. And the final example is also the harmonic mean of the probabilities, right? I did not play with the absolute values. Now, if you ask me whether, if you convert the problem statement to predict the next data rate, ideally what my intuition says is, in that case, using only three lag values, it would be better to use more lag values, more past values to predict the next data rate. And so the solution of this problem statement was a mix of tabular data and time series feature engineering. When you try to predict the next data rate, the ratio of the features, the ratio of the type of features that was created, as of now it was 50-50, but in that case mostly we will be moving towards more lagged values, more rolling mean values, right? More features basically which show the increase and decrease in the trend of the data rate. And so there's an ongoing competition also. So the only problem there would be for the network stations where we do not have history or lesser history, there we would see not good results. For example, I also did an error analysis. So I also wanted to understand, why do we only have 75% F1 score? Can't we go to 80%? And when I started analyzing the results of the model, the network IDs where we were failing miserably were the network IDs where there was an anomaly in the next hour, right? Basically the data rate was 000 and in the next hour it was 70, right? So model could not have known that, and that can be countered using the location. Using the location we could cluster, and the traffic scenarios and the other intuition could come.
Okay, yes. No, I mean, it's clear that as I don't remember which of the participant was saying before, there are intrinsic difficulties in this challenge, the stochasticity of the traffic, etc., which have a large impact on the results itself. So, yeah, probably using some feature, additional feature like context related feature that you, as you were saying, is also a good idea. Thank you for your answer.
Yeah, Krishna, thank you so much. It's a very interesting presentation. The way I really like the way you put it as well. Very nice. I think a couple of observations. Your choice of finding the delta, how far behind the time, how far behind in time the fault occurred, is quite interesting choice. I mean, I was trying to find out whether it is domain-wise it makes sense. I've worked on the domain, so I'm not sure whether it makes sense, but it's an interesting choice nonetheless.
So the idea, sorry to cut you, Vishnu. So the idea was just that for the data, for the network IDs where we have the data just before, for the just before hour, the model should be more confident towards predicting the value.
I
So
see.
that was the intuition.
Interesting. I want to ask, maybe did you look at does the time of the day matter? Because when we are discussing time, so that's why I'm asking. Did you, in your intuition, Does the time of the day matter? And I believe this is somewhat related to maybe the positioning aspect that you are saying. I mean, latitude, longitude, etc. Right? So maybe it is related to that as well. I will let you answer in a bit. Another interesting observation is the correlation between the parameters. I think you really put the data set and the EDA correctly. And in that, it is quite clear that there is a correlation between the data set, which could probably answer your questions about maybe instead of using positions. I believe Antonio just now mentioned this aspect also. There are some features which are quite interesting. But overall, very nice. Yeah, thank you so much.
Okay, thank you so much for the Q&A and for the discussion. Right now, we have received apology for one presenter, so we are going to have one last presentation, and instead of 5, we are going to have 4 presentations for this finale. And the last but not least, we have Adetomiwa. The floor is yours. Good afternoon.
Hi, good afternoon. Thank you very much for the opportunity. So, let me share. So, my name is Toma. This is my presentation. So, the data set had historical hourly data from 2,800 unique networks. Okay, sorry. And the aim was to predict the average data rate change at the time when faults occurred. So about 2,135 NEs had one ID each, like there was a kind of hierarchy attached to the NE networks representation. Then 750 had between 2 to 42 IDs unique. And faults occurred at least at once in most of the NEs. Data aggregation for the proposed solution, daytime features were extracted, and provision was made for NEs with fewer data samples. Historical values like only the lag data rates and trends were aggregated, and it was sufficient for the model performance because it was kind of representative of all the other KPIs. So addition of other lag KPIs did not improve the model performance. Then cross identification for the different ID. We didn't have kind of metadata for the networks, but based on the hierarchy and the identification, I was able to group, identify IDs by that and proper target definition. So I trained with all available data rates, irrespective of whether fault occurred at that hour or not. So for each NE I train with samples from all NE, whether fault occurred or not. So just with the target of whether data rates increased or not at the next hour. So this provided a lot of training data for me. So at the end, I had over 900K training data for prediction and to remove the problem of class imbalance, because I had enough classes of positive, enough negative and positive classes. This is the kind of hierarchy I was talking about, and it's kind of a way that might improve the model performance if we look more into clustering and grouping the NEs together. Then I model selection, I selected light GBM classifier because it's fast and it improved my local validation. Then I used 1,000 estimators. I trained 2 models, one with lag features, one without lag features. The one with lag features had total of 154 features. The one without lag features had only 31 features. The one without lag features was used to predict NEs without historical data or sufficient data rates. And so used for baseline for monitoring model accuracy and performance. And it can be used as backup in case aggregation pipeline fails. Threshold of selection because I predicted class probabilities, and threshold of 0.4 was used to identify positive classes. So this kind of representation of how my model performance changed with the threshold. At the normal threshold of 0.5, my model performed, my F1 score was below 0.72. but at around 0.4, my model F1 score was above 0.74. And this kind of my feature importance. And the one instantaneous feature that was extracted was like for duration multiplied by the relation. So that's like a feature that improved the performance of my model. Then the choice of classification threshold has also been used in the past in previous problems involving anomaly detection, and it also proved useful in my own case for this problem. Then my data aggregation time to aggregate lag features took about 24 seconds. Training time with lag features took only 5 minutes. Prediction time with lag features 200 milliseconds. Training time without lag features 13 seconds. Prediction time without lag features 21 milliseconds. Technology, I use Python, LightGBM, Pandas. My processor was CPU, 8 GB RAM. And like I said, I trained on over 900K of data. So at the end, my LightGBM model was able to predict average data rate changes at first hour when a fault occurred with mean F1 score greater than 0.72 using historical data rate trend and manual threshold selection of 0.4. Thank you for listening. That's all from me.
Thank you so much for the quick presentation. I would like to open the floor for Q&A. So Antonio and Vishnu, the floor is yours.
Thank you, Toma. I appreciate your clear presentation. Also, I think you have a very good score with your model. I want to ask you, so first of all, what do you think was the largest challenge in this problem?
Yes, the largest challenge was aggregating the data. Like I said, I first started with a kind of regression approach before I now started aggregating the data with the different NAs and whether faults occurred or not with the hourly presentation of the data was a challenge. And depending on the aggregation method, the class balance changes. So sometimes, okay, you will not get up to 50% class balance, depending on how you aggregate. So aggregating the way I did was able to solve the problem of class imbalance, and I was able to get enough training data to train my model. Then the first approach of regression did not really seem helpful. I was trying to really predict which way, but it didn't work. But when I took it through, approach the problem with classification, my model performance improved.
Thank you.
Yeah, thank you very much. It's a quite clear approach, as Antonio told. I think your observations of data aggregation is actually quite interesting. Thank you so much as well. Maybe can I ask on the boosting approach? You mentioned about monitoring, baseline monitoring, thresholds maybe, and the selection of lag features, etc. Right, in boosting. Could you explain the baseline for monitoring and how are there some things to keep in mind there? Are there some things to which were challenging there at all?
Yes, like the baseline is to just use instantaneous features available at that particular hour, not using lag features. With this approach only, you get like if you're looking at F1 score, you get F1 score like 0.72. So when you're using lag features, so for a particular window, let me say for a day, you expect the accuracy you get from using lag features to always exceed when you're not using lag features. So if at any point the accuracy you get with the lag features drops below that, then that means the lag features are not really doing anything, or that means there's a problem or a data drift in the aggregation pipeline. So that's just the point of having a baseline and another prediction.
Thank you.
Okay, so perhaps we can have we have some questions on the neural network. Vishnu, you can check them out, and we can have some 5 minutes to just have like overall questions for all the participants, for all the presenters who have presented here. We can just have an extra 5 minutes to ask them maybe questions that anyone can pick up and answer, and then we will go into the next phase of the award ceremony. So Vishnu, over to you.
Yes, cool. Okay. Yeah, that's exactly what I wanted. Okay. Yeah. I believe you know, the common factors, right? I think if you look at the common factors, the boosting approaches, I mean, the data exploration and cleaning and aggregation approaches, and then this kind of model selection and then boosting approaches. Finally, the threshold and the final result. I believe that way there is a close competition. Maybe what I want to ask is something okay, so about the data set, right? Did you find anything which you think is missing from the data set? Maybe what I want to ask is that when you there were some things which you already called out. I think the participants already called out the exclusion of rows, which was already mentioned, the reason for that and so on. But in your pacing of when you start analyzing the data towards the final result, right? I want to ask in terms of pacing the whole process. That means you start analyzing the data, then you try out some approaches, and then you look at the result and do some optimizations, right? So if you look at this kind of splitting of your process, maybe can I just go around the table and ask what is the time which you spend, and what are the specific specific time points where the complexity was felt. So I want to ask maybe Julius first. Yeah, Julius, could you explain, like, how did you pace your work? What kind of was it regular that you did, or did you do in a specific time periods that you did the analysis, or what did you do?
Thank you so much, Vishnu. I would like first to point out the difficulties that I saw in the discussion forum on the site where the competition was hosted on Zindi. And I think some of the contestants, they really faced a great challenge creating the label. Will a fault cause the data rate to increase, where you label it as 1, or will it cause it to decrease, where you label it as 0? So there was so much concern about how we created the label. And I think some of the participants, maybe that's where they maybe they could not perform very well in the competition, because if you did not really understand how to create the label, you are just given the data rate, and then we were to create the label ourselves. So I think there was some difficulty there. For me, as I said before, my data was quite huge because I combined the train data set and also the test data set to about 900,000 rows. And then later on, I separated, of course, my predict the rows that I needed to predict the 1,900 later. So my data set was a little massive, and that one made the training quite maybe slower. But of course, the inference is very fast because I'm only using 37 features in total. So maybe the training bit took a little time, around 3 minutes, as I pointed out earlier. That's what I could comment.
Yeah, cool. Thank you, Julius. Isak, could you tell us about what your experiences are with the data? Did you find specific challenges, and how did you go about processing the data itself? Did you do regularly, or did you do it weekends? or what is your general experience with processing this data?
Okay, thank you. And the data set had almost 1 million rows when we combine test and the training in each hours. And when we take the mean, when we try to mean coding, we need to compile inherent test data that is lays before fault row. So when we try to call a group by something like a network ID and the hour, then when we complete the quantal, especially, is so it's so need a huge computation power. I try to do that, but I can't to use in computation power. That was a problem. And another thing is that's the challenge.
Okay, yeah, thank you very much. Krishna, what would you add, please?
Yeah. So for me, so I remember my first submissions scored 72% F1 score on the leaderboard. So from the get-go, one thing was very clear, that for a particular network ID, the data was not only present in that particular CSV chunk, it was also present in other CSV chunks. So the first intuition was to add up everything and sort by network ID and timestamp, right? And the first intuition after looking at the target variable, after creating the target variable, the first intuition was that this is an imbalanced problem. So scale pose weight had to be tuned in according to the local leaderboard. So after the first submission, basically taking it from 73% to 75% and introducing a second set of features and third set of features, and model tuning in terms of a feature fraction and other things, so that the model does not overfit on the training data. That was the time taking step. Other than that, it was all good.
Okay. Yeah, actually that reminds me about our previous discussion. Yeah, that's on that network element ID and your comment on GPS. I believe it would be quite interesting to combine your approaches with what we think are the relationships between the columns, between the features. That's what I was trying to get at, and I believe that's the same thing that Antonio was mentioning as well. I mean, there are specific correlations which maybe can address the question that you're asking in terms of location. I mean, the location is useful if you really have external data, like, for example, did it rain that way or something like that. Otherwise, your requirement on pinning the data to a particular network element, that can be addressed in other ways. I think there are ways of addressing your point there, but point well taken. I think that's a quite relevant point that you're asking. I want to finally ask.
Maybe Vishnu, I can add also that regarding what you are saying, that base station or network nodes, which maybe are very close, maybe they are actually serving different type of traffic, because maybe one is indoor and the other is outdoor. One is in a shopping mall and the other is actually on the street. One is in a given location, maybe very close, but they are pointing on different areas. One is pointing toward the highway, and the other is pointing down in the office, in an office in front of the base station. So the location itself, it's useful, but it doesn't provide that much information. Maybe, as you were saying, there are other feature, other way of extracting more relevant information.
Yeah, it's actually a good point. I'd forgotten about the indoor-outdoor distribution, but yeah, you're right, Antonio. Let me just quickly check with Aditomiwa. Are you there? Is there anything which you would like to add to this question? Please.
Yeah, I just have a bit to what Julius said, defining the targets, like you are going to predict, because I told you my first approach was regression to predict actual data rates. So this was like intuitively what I thought was going to be the way to go, but the results and cross-validation showed that that was not possible. So for preparing the classification task and choosing to use whether data sets where false occurred or false did not occur was also very crucial. And I think the public and the private leaderboard, there was this kind of slight distinction in because you see that when you do very well in the public, the private score dropped, and that's why the importance of cross-validation cannot be underestimated, and you have to trust your local and try to create a kind of very good cross-validation strategy. So that's all.
Cool. Yeah, thank you so much. That is Thomas. All right. Yeah, back to Thomas.
Thank you so much. I think everyone knows what time it is to announce the winners. After a long time, a few months of hard work, I think we have to reward people for their hard work. And I would like to go into this last but one part of our session, which is announcement of winners. And the winners will receive a certificate from ITU. And of course, some interesting background music to just make it interesting. Okay, so we are into the last part of announcing the winners. I'll give it to Antonio. Winners. So Antonio, the floor is yours.
So the first in the rank is Aditomiwa Adedeji, and motivation is very good score, good model design, also very nice presentation from Aditomiwa. Congratulations.
Okay, so congratulations to Aditomiwa for being ranked number 5. And for this rank, you have, we will transfer 500 Swiss franc. And of course, yeah, we will be in touch for the other things.
Congratulations.
Thank you very much.
Yeah, so to go to the next one, just a moment. Okay, Antonio, check your message. Okay, so we are going to the next announcement for number 4. Maybe Antonio, you can first. What is the motivation for giving out this prize to number 4?
I think this participant has very good score, very close actually to the one of the Mia. Maybe just a slightly better report from my perspective. That's the reason we gave number 4 to this participant.
Okay, let's know who it is.
Chibuzo Emelige, who unfortunately is not here with us. Congratulations anyway, Chibuzo.
Okay, so we are continuing with the awarding this people who have done great for this problem, for the problem statements. Next is 1,000 Swiss franc to Antonio, who is receiving and why are they receiving? First, why are they receiving this money?
So I would say this was a very good, very good report. The report that I liked the most, and he got very good score. Unfortunately, his exploratory data analysis was a bit limited with respect to the other participant. So that's why this participant has been ranked 3rd. And his name, sorry, is Julius Mangui. Congratulations, Julius.
Okay, congratulations, Julius, and of course we will be in touch for your money and the certificates and everything else. Now we are going to the number 2. Okay, why are we awarding this?
So number 2, I think the most important motivation is rich temporal feature analysis. Very interesting exploratory data analysis. It really clarified the way in which he proceed to construct his model. We really like this. Very good business value in his methodology. And yeah, participant name is Isak Biranu Bule. Congratulations, Isak.
Congratulations. And of course, we are going to the final one. Okay, so this is the overall winner. Antonio, please.
So, okay, I think the first, the winner has a very good problem understanding. Very nice exploratory data analysis in line also with the business requirement. Congratulations for his great work.
Of course.
Congratulations, Krishna.
Okay, congratulations to Krishna for winning the overall prize. So you win 4,000 Swiss franc. And of course, unfortunately, you are not a student. So we'll have to check to the other student participants if they can be taken for the internship in Huawei. But maybe if you have a few remarks you want to make, quick ones.
So thank you. First of all, thank you so much for a very interesting challenge. And I have also been participating in the several challenges of ITU. And thank you so much for giving us the real data. It's not a synthetic data. It brings it gives us a lot of insight, and it's a very the process of solving the problem using the real data is very nice, and specifically the domain. This domain is relatively very new. So thank you so much for.
Thank you so much. So as we are going to close this session, I would like to give the floor to Antonio and Vishnu to give some closing remarks before we finish the session. Antonio first and then Vishnu.
On my side, I want to thank all the participants and in particular as well ITU and Zindi. They make this challenge possible. It was very nice to work with you. And I hope that there will be further opportunities in the following challenges to collaborate together.
Yeah, I completely second what Antonio told. I remember our initial discussions with Antonio. We have come a long way. Thank you so much, Antonio, for that great support. And as Krishna mentioned, it is real data. Thank you so much for coming up with the real data. Congratulations to winners. I think Krishna is so happy that he is unmuted. So yeah, congratulations Congratulations to the winners. Thank you so much for participating. I believe the papers, Antonio will take it forward, I hope. And it is very important that we publish what we have learned. Now we have gone through this process, and you have gone through this process. So it will be very interesting to document this, the current challenge. And as Thomas mentioned, we would have papers coming out of this. It will be really interesting to look at this work which you have done to be documented as a paper. We would have ITU journal, but you're free to publish anywhere, but we would definitely host ITU journal. That we have done in the past as well. So thank you again.
Yes. Quickly, well, I want to say to the participant, maybe I can also contact you, but as well, this can come from your side. If you want to publish your contribution in this ITU special issue or elsewhere, feel free to contact me either as a single author or as also group of participants to compare their solution. We can do, I think, a nice publication if you're interested.
Excellent. Yeah, thank you so much again, Antonio, for taking that forward and the support again. We would like to, I personally learned a lot just going through the process of working with Antonio and colleagues on the all the way to the current set of presentations that we have. So I'm sure next year we will meet again with V2 plus challenge plus fault impact analysis plus. So yeah, we will see at that time. Back to you, Thomas.
Thank you so much, Vishnu. Thank you, Antonio, and thank you everyone for participating in the challenge, for presenting. And of course, the winners, congratulations. So as you already know, we are publishing a special issue. Please submit your contributions. We'll be happy to help you in any way possible. But also we have several other ITU competitions open. You can participate and win more money, win more prizes, and of course, network with other data scientists or AI ML scientists or engineers. So please participate in our events. We have regular webinars, but also you can check our programming at the AI for Good. At this point in time, I would like to close, and over to you, Anna. Thank you, everyone, and have a good day.
Thank you.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.